Ross. I think with that, we'll move on to our second speaker. One of the nice things about ECSS is that there's such a wide variety of activities that we're all involved in. We're going to switch gears quite a bit here. Marlon Pierce from Indiana University is going to talk to us about the Open Gateway Computing Environments work with the Apache Software Foundation. So this is really interesting work about open source software and community contributions and kind of the whole governance model and contribution model that it takes to really accept a wide range of contributions from the community. So with that, Marlon, I think that I've made you a presenter, and you should be able to advance your own slides.
Okay, thanks, Nancy. I'll give it a try. Is
Presentation mode is now enabled.
Can you hear me okay?
Yep, go ahead.
All right, so I'm on speakerphone, so please let me know if the sound's not good. And also, it was an excellent talk that we just heard. So anyway, I have this quite lengthy title about developing software tools within the Apache Software Foundation. So the subtitle here, which is I'm going to try and expand on, is the Going Beyond Open Source. And hopefully I can advance. What do I need to do to advance?
You should towards the top of the web. Yeah, there you go. Yeah.
Got it. Okay, so I'm also going to start with my final slide, which is the acknowledgments. So a lot of this work was done by the IU Science Gateway Group, and then also our collaborators through a couple of rounds of NSF SDCI funding for the Open Gateway Computing Environments project. So hopefully I didn't omit anyone important here, but this is a list of our collaborators. And I'll also say that a lot of this Apache involvement is the brainchild of Suresh, so this is a really, I think, important. We're hoping this is an important step for the gateway and cyber infrastructure communities generally that we're trying to take. So the two pieces of software that are kind of our case studies that are the underpinnings of all the higher level considerations are the Apache Rave and Apache Airavata incubators, which I'll say a little bit more about in a second. So key problems for Science Gateway software and cyber infrastructure software generally is our reusability. So especially in gateways, we often see the problem of people just who want to set up a gateway having to decide whether they want to reuse some gateway software or write their own. And I think typically in the gateway community, we're going to tend towards writing your own gateway software. This does lead to sustainability problems. So gateways are often associated with small teams, or typically, I guess almost always small teams, which has some problems. If you lose your key developer or key person from that team, does that kill the project? And also, successful gateways become hard to fund because they become infrastructure and they don't become interesting anymore as a research activity. That combined with small teams, it makes it also hard, if you go to your local university, if you can't go to the NSF anymore or whatever, can you go to the university and ask for funding to keep a few FTEs around to run this gateway? You really have a hard time, I think, especially in the current economic environment of keeping things going beyond the 2 or 3 years. A lot of these topics and other topics in sustainability and reusability have been covered in a workshop report that I reference here, and I'm not going to say more about that. The third bullet, I think, is something that doesn't get considered a lot compared to the first two, and that's what's your governance model. So once you have software base for your project, and maybe you're going to, if you go through SDCI or probably SI squared, you're going to be required to have some open source licensing. But what about your governance model? So how are design decisions about that open source software going to be made? Who decides things like when the software is suitable for being released? How do you handle contributions? So hopefully you're getting reused. So when you get reused, people are going to start finding bugs and wanting additional features and things like that, and hopefully they'll also be contributing bug fixes and patches and other things like that. How do you handle those things? And more importantly, how do you get those people actually invested in your project directly? How do you encourage those sorts of contributions, and how do you let the developer know that that bug fix is actually going to be applied, that and that developer is going to get his or her reward for doing that and proper acknowledgement. So the solution we're proposing here in this talk, and this is a work in progress. I wouldn't say we've got the mathematical proof of this as being true, but our solution is to go beyond open source to what I'm going to call an open community software model. So this is more than being on SourceForge or GitHub or Google Code, and those certainly are excellent tools to support open source projects. But what we're really concerned with is community building. So how do you get a diverse community of developers together? And if you get that, hopefully that starts to mean reusability and sustainability. Not magically, but it's I think an important precondition. But then if you have that diverse community together, you're going to have a governance model. So some open models, examples in CI. This is prior art that I want to cite, and I won't claim this is the full list of anybody who's ever pursued a successful open community model. I think all of these are also, or at least the first three are probably familiar to the people on the call, and they would make excellent topics for a future presentation. I would like to highlight briefly the last two. I think the ENSO project has done a really interesting job in trying to make itself an open source, open community science project. So ENSO is probably most of you know is a famous astrophysics simulation code that Mike Norman and other people have been involved with for a long time. There was an excellent presentation by Brian and O'Shea at TG11. I know Brian's willing to give out his slides. They're not available from the website, but certainly he can provide them. And I think it's an interesting example of a science code community trying to make themselves into an open community project, which is a little bit different from what we're talking about here because they have scientific reproducibility problems that they have to solve, which are a little bit different metrics than your typical science IT project. And the last one is Apache ODT and also the Tika data management projects, which are predated us by about a year into the Apache Software Foundation. Those come out of NASA JPL, and they're sort of groundbreakers along with us and trying to get Apache to start taking into consideration cyber infrastructure. So I'm going to briefly go through two Apache, the Rave and Airavata use cases that I mentioned. So we've talked about these in previous talks by me, by Suresh, and so on. So I'm not going to say a lot except Apache Airavata is the OGC workflow suite. So these are codes that had their original life in the lead science gateway through OGC. We've applied them to a number of other computational domains, computational chemistry, nuclear physics, bioinformatics, etc. So it's a comprehensive suite of software to manage applications on grids and clouds. So because I made you look at too many wordy slides, this summary figure here illustrates the different components of that Airavata software and the Airavata project and how they kind of relate together. So there's application wrapping. Kind of at the center, this exposes command line applications on grids and clouds as secure services. These can be composed with, on the left-hand side, the XBEA composer, which can also execute them or can hand it off to another service not shown here called the workflow interpreter service that can actually execute. The workflow notifications get sent to a message bus that's the WS Messenger in the top right, and so it's a publish subscribe system. So lots of things can subscribe to those notifications, including XBEA, which is also it's a screenshot of XBEA at the bottom right. So those components can be used individually or all together in a single application. And then one quick other screenshot. This is a nuclear physics workflow that we put together in collaboration with James Berry's team at Iowa State. And this is actually running on. This is actually not an Exceed workflow, but actually running on DOE machines, or Franklin in particular. So that's one Apache incubator. The other Apache incubator is called Rave. So this is a open community software for enterprise social networking, shareable web components, and science gateways. So this is a little bit different in organization from Airavata, which, although it has alumni or has people in the project at WSO2 and IBM and a couple of other organizations, these are basically alumni of the lead in OGCE projects. And so that project, our goal is to expand that developer base to meet some Apache diversity requirements. With Rave, we actually already meet those diversity requirements. So we developed, and as I've talked about in previous TerraGrid and other venues, a piece of software called the OGC Gadget container, which was basically doing stuff in bullet number 1. Well, we were invited to give a presentation at a open social. That's a specification for social networking. We're excited. We were invited to give this presentation at that workshop, and it turned out that there were 2 other groups doing almost exactly the same thing, one from MITRE and the other from SurfNet. So we were invited to, and so the Hippo software and the person by the name of Vate Duma who works for Hippo is also a long-term Apache contributor and so forth, and he invited us to, the 3 of us, to join together to form the Rave project. So we did that, and we also basically rewrote all of our, not reused anybody's code here, but actually it started from scratch on the entire Apache Rave framework, although it more or less implements same features as its 3 earlier incarnations. So this slide again is just to illustrate some quick features. Rave is initially intended to be a way to support enterprise like iGoogle systems, social networking systems, things like that. So on the upper left, you have examples of various gadgets that are running inside of Rave, and then you have a gadget store view on the lower right. It would also say that Rave exposes all this stuff as at the API level, so you don't actually have to develop gadgets to use Rave. You can use Rave as a backend service, or you can. It's also developed in Spring MVC, and so you can actually develop native JSP or actually both Spring web front ends that you don't have to go through the Gadget API to make use of Rave if you don't care to. One last thing about Rave before I move on to some of the higher level aims of the talk. Rave is designed to be extended. So part of this is just good design, which I'm not personally taking claim for, but you know, when you work in a distributed group and when you have a lot of people from different places who are trying to work together on the same code base, you know, it's all going to collapse, or else, you know, if you don't have a good, if you don't use good design principles from the very beginning. And I think collectively we've managed to do that pretty well. But also another interesting feature of Rave, and this is described in more detail in our GC11 paper, in which we presented 3 use cases. It's also designed to be extended without you having to fool around with the source tree. So basically, you can take the classes that you need to specifically override and replace those inside of a skeleton project and build against Rave jars. Anyway, so this is also important from the Apache point of view, because you know, science gateways have requirements that enterprise portals and enterprise social networking systems aren't going to have. Like, they don't care about managing my proxy credentials, things, or don't really worry about you know, some of the other things that science gateways commonly do. So approach keeps the core of the code really clean and generic, while allowing us to make profiles to support specific use cases with things that are not necessarily going to belong in the core of the or the main trunk of the code. All right, so the last section of the talk here is the Apache Way and Science Gateways. So why Apache for gateway software? I think one of the most important things, of course, anybody, you could certainly go out and put your code in GitHub and try and build a community around it. But Apache and groups have been successful doing that. But for Apache, it's designed to help make all those things easier and to shore up things that you might not care about or know about too well, but will need to know if you're going to really run an open source project. So the first thing, of course, is Apache software as a foundation, is a neutral playing field. It was designed from the beginning to encourage competing groups or competing companies to have a place where they could work together on common foundational software. And also, it does include a legal cell that provides expertise in handling legal issues associated with open source software. So if you're doing this all by yourself, chances are you don't have a good legal team backing you up at your university, or at least within your development group. The foundation itself is sustainable. So it's been around since 1999. There are multiple sponsors. Some of these have fortunes going up, some have fortunes going down, but on the whole, you have the ability of the Apache Foundation to survive because it has multiple funding streams. Third is that it has a proven governance model. So projects are, you can read more about this. I can certainly provide pointers, or you can use my slides as a jumping off point. But basically, all projects are run by a program management committee. And new projects must go through an incubation period in which they're mentored by experienced Apache members who are going to make sure that you do everything correctly and following the Apache way, which I'll say more about on the next slide. And again, Apache is not necessarily, they do provide infrastructure, SVN repositories. I think they have a Git repository now, and mailing lists and beacons build systems and things like this, but their real goal is to provide social infrastructure for building communities around software. So I think one of their mottos that's appropriate here is it's community over code. So, which is certainly not the way that a lot of open source projects start out thinking. And lastly, of course, there are opportunities to collaborate with other Apache projects outside our usual cyber infrastructure world and group of suspects. So there's certainly many other Apache projects which have something related which are using things, or where they're providing things that gateways are interested in, like Hadoop or maybe Access 2 and so on. But our goal here is to, not just be downstream consumers of that software, but actually have more of a two-way collaborations with the developers of those types of software. So the next slide is a little bit about the Apache Way, and it's certainly not the definitive list of bullets, but I'm trying to provide just an overview. So the projects, as I said before, start as incubators with one champion and several mentors. If you're going to do this, by the way, making a good choice is very important. Again, because you want to pick somebody, or you want to pick champions and mentors who are going to have a lot of experience and a lot of influence within the Apache project when it comes time for you to graduate. So graduation is judged by the Apache community through open mailing list votes. Everything is democratic, +1 or -1. So, in order for you to graduate, you're going to have to do various things, starting with having, and your mentors and championers are supposed to oversee this, and you're going to have to make sure you have good open engineering practices. So one of the interesting things, and something that when I mention this to other people, they think it's almost, so old school, it's so primitive, but basically everything has to go. There are so many other places to communicate now. Why use mailing lists? But mailing lists, and specifically the developer mailing list, are where all the discussions, all the decisions, all the communications for the project happen. And that way for a reason, in that those things, you have a trail of how decisions were made. So it's a requirement that all these design decisions get made by the community in a way that you can go back and you can Google, you can find in the archives very easily. Also, JIRA contributions. So JIRA is a technology, I guess, or of course it's a issue tracking technology, but also it's a way for the community or for a project to track its design goals and to break all those ultimate or large design goals down into smaller components that actually correspond to contributions to the SVN or whatever code repository. And also, when you want to take in contributions from non-members of the project, like patches, those go through JIRA, which is going to also take care of legal issues associated with contributing. Next two bullets. So first, you have to have also, besides good practices, openly and properly packaged code. If you're following our Airavata list, you might notice we're really having a lot of fun trying to get all our licenses and notices and things like that worked out. Certainly, it's not something that we would ever have done if we didn't know we were supposed to. This is even though it's a little bit of an annoyance, it's something that we really have to. Once we get it worked through, we'll really never have to do again, and we'll have proper legal releases of open source software, not just putting code on SourceForge and making claims about it. Of course, also you have to be able to build out of the box. Releases are signed, and like everything else, when it comes time to release, people vote on it, and you can not necessarily veto it, but you can, if you don't like a particular release and you're on the mailing list, you can express your opinion. It may not be binding, but it will definitely be registered, and typically it does not come down to a pure plus ones added up and then subtract all the minus, or then add all the minus ones, but rather what you're trying to achieve here is consensus that yes, this is a piece of software that's ready to be released. The last one is also very important. That's developer diversity. This is a requirement for graduation. You have to have at least three or more unconnected developers, rather. And the idea is that, and that's a relatively small number. Most projects will have a lot more, but having just a lot of developers is not enough for graduation, because all those developers could work for the same company or the same university and be on the same funding, and if that goes away, then that project dies. And so what Apache wants to see before you graduate from incubation is that you have attracted developers from other places who are actively contributing to your code base. And so when they see that, they start to know that this is code that's going to survive the loss of a funding stream or a particular single developer and so on. At least have a chance to. The price, of course, is you give up sole ownership, and you replace that with a meritocracy. So, when you donate your code to Apache, if you graduate, if Airavata graduates, it's not going to be owned by Indiana University or our group. It's owned by all the developers or rather all the program committee members and all the contributors on the project.
Probably time to start wrapping up if you can, Marlon.
Yep, I'm moving along as fast as I can. So this slide just reemphasizes slides in the previous, or the points in the previous slide. So I will move along and say two other things that are important if anyone is interested in this. One is that Apache committers and PMC members aren't just code writers. Successful communities also include, important users, project evangelists, content providers, people who test software, provide good requirements, provide constructive complaints and criticisms. All that stuff has to go through the mailing list and so on, and basically anything else that needs to be done. If you prove yourself useful to the project community, not to the code base, but to the community, you can get voted into the PMC, and then you have the right to cast your vote on every major decision, which, as I said earlier, is all going through the open communication channels. And then the last slide, how to get involved. This is true for any Apache project. First thing to do is join the dev mailing list and grab the software and start complaining about it. Post Jira tickets. So if I'm sure I'm talking mostly to people who would be interested in committing code as opposed to some of the other things that you wind up doing or that you could do to become a member of the PMC. But the quickest way to join a project is to start submitting patches and Jira tickets. And when those get contributed eventually, and every project is different, there's no set number of tickets or patches rather that you have to commit. But after all that's done, or after a while, you'll get voted into the project. So again, every project is different. But speaking for our two projects, we're certainly interested in getting contributions, and we've certainly added a few outside committers already, and we want to expand that circle. So with that, looks like I'm 3 minutes over, and so that was my last slide. Thanks, everybody.
Marlon, thanks. Let me open up the phone lines here.
Presentation mode is now disabled.
Okay, great. I think this is going to be something really important for our ECSS staff to at least be aware of. As you pointed out, there's more emphasis from the NSF on sustainability, and I think we're going to see, even for the science codes, like you mentioned, Enzo, just being aware of something like Apache and the ability to kind of pursue this route, I think is something that some of our ECSSers may want to have in the back of their minds as they're working with their user communities who might not know about these sorts of paths and this sort of approach to sustainability. So very nice talk. Thank you very much. Do we have any questions? I see a number of Gateway developers on the call. I know a few people have dropped off with the top of the hour. Anyone have any questions for Marlon? Okay, hearing none, the slides for both of our presenters as well as their contact information, if you think of questions after the fact, they are up on the website. And with that, I will conclude the call and figure out how to turn off the recording here. Thank you very much, everyone.